Okay, so the techniques we learned in the last lesson only apply to right triangles. So here, if none of the angles of a triangle is a right angle, we call that triangle oblique, which means that it will either have 3 acute angles or 2 acute angles and 1 obtuse angle. Now, for the problems in this lesson and the next, the triangles will always be in this fashion, where angle A will always be opposite side A, angle B will always be opposite side B, and angle C will always be opposite side C. That's just a designation for this lesson, but if you have a real life triangle, we're not calling the sides A, B, and C. So what we're going to be doing today is we're going to be solving oblique triangles, which means we are trying to find the lengths of its sides and the measurements of its angles. We can't use the techniques from last lesson since they only apply to right triangles. In order to solve a triangle, we need to have at least 3 measurements of a triangle. Now, we could have either the sides or the angles. However, one measurement has to be a side. If they give you 3 angles, you cannot find the exact measurements of the sides because then you just have a bunch of similar triangles. If you remember from geometry, similar triangles had the angles being congruent. The sides didn't need to be congruent. So we have a couple of cases here. And in this lesson, we are going to focus on case 1 and case 2, which are when we have 2 angles and a side. So either you could see it as angle side angle or angle angle side, or the third one, which they did not you can't use this to prove congruence, but if they give you an angle and 2 sides that are right next to each other, it's a SSA triangle. These type of triangles can be solved using the law of sines, whereas the other 2 triangles are going to be solved doing the law of cosines. Now, and this lesson we're just going to focus on the law of sines. So the law of sines is this: the sine of an angle over the side that's across from it is equal to the sine of another angle over the side that's across from it. Now, it doesn't really matter which sides and which angles we use. You just have to make sure you always pick the angle and the side that's across from it. So look at example 1. We want to solve the following triangle. So first thing I know is that the angles of a triangle add up to 180. So angle C here is just going to be 80 degrees. Okay. Now, to find the other sides, I'm going to use my law of sines. Remember, you cannot use SOHCAHTOA here because it's not a right triangle. So what I'm going to do is I see that I have 40 degrees and across from it is 4. So I'm going to put sine 40 over 4. And if I want to find, like, let's say side B, is going to be equal to sine of 60 over B, because the angle 60 degrees is across side B. So that's how it looks like. Okay. And then now to solve this, we just go ahead and we cross multiply. So this is B sine 40 is equal to 4 sine 60. And then we divide both sides by sine 40. And then enter that into your calculator, and you should get B is around 5.39. So now if we're going to find side C, we're going to go ahead and do the same thing, where I have sine of 40 over 4 is equal to sine of 80, because remember, C is 80 degrees over C. Now, technically, you could use, you could do it sine of 60 over 5.39. But remember, 5.39 is an approximation. You want to try to do things as exact as possible. So to solve c, you just go ahead and cross multiply. So I have c sine 40 is equal to 4 sine 80. And then just go ahead and divide both sides by sine 40. So c is approximately 6.13. And so now you solve the triangle by getting the angle and the two sides. Okay. Let's move on to example number 2. Okay. So for example number 2, you want to solve the following triangle. A is 35, B is 15, C is 5. So you don't have a figure, but I already know that I could find angle C because the angles of a triangle have to add up to 180. So I know if I do the math here, C is equal to 130 degrees. 130 plus 35 plus 15 is 180. Now, since I get this angle, I know that the side across from it is 5. So I don't even need a picture. I could just go ahead and do the law of sines. Sine of 130 over 5 is equal to the sine of 35 over A. Because remember, if capital A is 35 degrees, the side across from it, we put it under. And so now we just go ahead and solve this problem by cross multiplying. A sine 130 is equal to 5 sine 35. We divide both sides by sine of 130. And A is approximately 3.74. Now, if we need to find sine of, if we need to find side B, we just go ahead and start by doing the same thing. We do sine of 130 over 5. Remember, capital C is 130. The side across from it is 5, so that's why it's sine of 130 over 5. And this is going to be equal to, we are looking for letter B. So this is going to be sine of 15 over B. We just go ahead and cross multiply. Divide both sides by sine of 130. And so B is approximately 1.69. So you could go ahead and do the DIYs on your own. So you could pause the video if you need be. And then I'm going to go over the DIYs. Okay. So DIY number letter A. If I know my angles are 45 and 95, then I know the other angle is 40 degrees. So A is 40 degrees. And now we're going to use our law of sines to go ahead and find the other sides. So I see in my triangle 95 and 5 are across from each other. So I'm going to use sine of 95 over 5 is equal to the sine of 45 over B. Now we just go ahead and cross multiply. B sine 95 is equal to 5 sine 45. I divide both sides by sine of 95. And I get B is around 3.55. And I just do it again to find A. So sine of 95 over 5 is equal to sine of 40 over A. cross multiply, I get a sine 95 is equal to 5 sine 40. Divide both sides by sine of 95. And so a is approximately 3.23. And that's letter A. Now, to find letter B, I know angle C is going to be 100 degrees. And so I have 100 and I have the side across from it is 2. So I just do sine of 100 over 2 is equal to sine of 40 over A. So this becomes A sine 100 is equal to 2 sine 40. I divide both sides by sine 100. And so A is approximately 1.31. And if you actually look, angle A and angle B are the same thing. So you would just do the same calculation and arrive at the same answer. So both A and B are 1.31. Now, we're going to talk about if they give you two sides of a triangle and an angle opposite one of the sides is known, the side-side angle triangle. It is referred to as ambiguous case because the information may result in one triangle, two triangles, or no triangle at all. So let's look at the next example. I have A is 2, C is 1, capital C is 50. I already have one side across from one angle. So I know that I'm going to use law of sines here. So I'm going to do sine of 50 over 1 is equal to sine of A over 2. Because we're looking for that 2 here, right? Now, if I do this, if I multiply, if I cross multiply, I get sine A is equal to 2 sine 50. Now, if you do that on your calculator and you do 2 times sine 50, you get a value of 1.53. Now, remember how to solve for A. You're going to take the inverse sine. However, when you do this, remember, the inverse sine the range of sine is between -1 and 1. Since 1.53 is over 1, this has no solution. And you could even put that in your calculator and you'll see you get an error. Okay, you should try it out. So that's this triangle is actually does not exist. And what the figure would look like actually is you would have a triangle that has a side of C, which or A is 2. It would have a B. And then like it would have, since C is 1, it doesn't connect down to the B. That's what's happening in this situation. That's why it's no solution. Okay? So let's go to example 4. Now, example 4 is when you have one solution. So we want to solve the triangle A is 3, B is 2, A is 40. So I have lowercase a and capital A, and I have lowercase b, so now I could use law of sines to find my angle B. So what I'm going to do is I'm going to do sine of 40 over 3 is equal to sine of B over 2. I go ahead and cross multiply. I get 2 sine 40 is equal to 3 sine B. Divide both sides by 3. And I get 2 sine 40 over 3 is equal to sine of b. And remember, to get b by itself, I'm going to inverse both sides. So the inverse sine of 2 sine 40 over 3 is equal to b. Now, I recommend that you enter it exactly like you see it. Do not do 2 sine 40 divided by 3, get an answer, and then inverse sine that, because that would be an approximation. So when you do this, you have to be exact. Can you come after school? Okay. So if I take the inverse sine of this, I get b is around 25.4. So make sure you could get that in your calculator, that this is 25.4 degrees. Now that you have angle A and you have angle B, you could easily find angle C, because 40 plus 25.4 is 65.4 degrees. And we subtract that from 180. And we get it's approximately 114.6 degrees. And now what we're going to do is we're going to use the law of sines again to solve this. So I'm going to use sine of 40 over 3 is equal to the sine of 114.6 over c. So by the way, this is angle C here. So we're looking for the side C. So now we just go ahead and cross multiply. I get C sine 40 is equal to 3 sine 114.6. Divide both sides by sine 40. And so C is approximately 4.24. Okay. Okay. Now, I forgot to mention here. When you find the angle B, you actually have to check when you do this inverse, okay, there's actually two angles that will get that have the same sign. So remember in a unit circle. Now the good thing about doing this chapter is that since we're in a triangle, we only focus to angles between 0 and 180. We don't do any angles here. But remember, there are two places that will have the same sign, one in quadrant 1 and one in quadrant 2. So when you get to this step, and I apologize that you're supposed to do this first, when you get to 25.4 degrees, you need to find the other angle that has that same sign. Okay? So if this is 25.4 degrees, the angle that has the same sign is 180 minus 25.4. Right? Because if this is 180 degrees and this is 25.4, to find this angle, I have to do 180 minus 25.4, and that gives me an angle of 154.6. Now, the reason why I just continued this problem without focusing on that is if this angle is 154.6 and this angle is 40 degrees, 40 plus 154.6 goes over 180, and that means I cannot have that triangle. So that's why I don't worry about this case. So I just go along and do this case. Okay? But now when we go to example 5, we have to worry about that second case. So I'm going to go through example 5 and I'm going to show you that process again. And the thing that I missed on the last example. So I have A is 6, B is 8, A is 35. So I know I have angle A, side A. So I could use law of sines here. Sine of 35 over 6 is equal to sine of b over 8. If I cross multiply, I get 8 sine 35 is equal to 6 sine b. Divide both sides by 6. And I get 8 sine 35 over 6 is equal to sine b. So I take the inverse sine of both sides. And I get b is approximately 49.9. Okay. Now what I have to do is I have to find the same angle. So this is the step that I missed last time. Right? In the half of the unit circle, if this is 49.9, I have to find the angle that has the same sine value. Remember, sine is the y value. So I have to find this angle here. Well, this is really just 180 minus 49.9. So my second angle is 180 minus 49.9. And that is 130.1. Now this is where I have to do a check. Look at 130.1 and look at the angle that I have here, 35. 130.1 plus 35 is 165.1, which means it's still under 180. And that means I have room for a third triangle. See, I want to contrast that with example 4. If I have 154.6 and I add 40, I'm way over 180. And so that's impossible for a triangle. But now here, if my other angle is 130.1 and I add 35, then I know it can still work because I could still have room for a second angle. So now what happens is two triangles can form. One where I have angle B of 49.9. So we're going to have two cases here. Case 1, B is about 49.9. And case 2, B is approximately 130.1. Okay? Now, in case 1, if B is approximately 49.9, then that means C is approximately 95.1. And in case 2, if angle B is 130.1, then I know angle C is approximately 14.9 degrees. Okay? So once again, there are two possible triangles that can happen from this information. So now what we do is we're just going to use the law of sines from each one to go ahead and find our last measurement. So to find side C, I just go ahead and do sine of 35 over 6 is equal to sine of 95.1 over C. We just go ahead and cross multiply. C sine 35 is equal to 6 sine of 95.1. We divide everything by sine of 35. And so C is about 10.42. For here, we do sine of 35 over 6 is equal to the sine of 14.9 over C. And so we get C sine 35 is equal to 6 sine of 14.9. Divide both sides by sine of 35. And I get C is approximately 2.69. And there. So in this problem again, here's the steps. You find angle B by using law of sines. Then you have to check what is the other angle that has the same sine. Now, once you do it, you get 130.1. And now you have to check with the original problem that you can still form a triangle with that. Since 130.1 plus 35 is 165.1, you still fall under 180, which means you have room for a third triangle. So now you're going to do two cases. One where angle B is 49.9 and one where angle B is 130.1. You find angle C for each of them and then do your law of sines to find side C. Okay? That is when you have two solutions to the information given. Okay, lastly, on this packet, you have, or in this lesson, you have a real world problem here. And you could read it to yourself. But the goal here is to find the height of the mountain. Now, I know this is a right triangle, so I could probably use my SOHCAHTOA to get here. But I don't really know any of these sides, right? I'm looking for the opposite. I have some of the adjacent to the angle, but I don't have this whole side, and I don't have the hypotenuse. So if you look here, what's happening is they're taking measurements from two different points. The difference between the measurements, 900 meters. Now, what would be helpful is if I had another measurement here so that I could use SOHCAHTOA to find h. So I could either find the hypotenuse or I could find this entire adjacent. Well, what I'm going to do is I'm going to look at this. I actually have two triangles here. I actually have three triangles here. I have the big triangle, I have this small one, and I have this other small one. If I know this is 35 here, can I find one of the other angles here? Well, the answer is yes, because this is a linear pair. If this is 47, the angle that's to the left of it is supplementary. So 180 minus 47 gives you 133. So I know this angle here is 133. And if I know this angle is 133, I could find this angle that's on top of here, since the angles of a triangle have to add up to 180. So I know this angle, if I have 133 plus 35, it is 168. And 180 minus 168 gives me that this is an angle of 12 degrees. Now I could use my law of sines to find this side here. Why would I want to find this side? Well, this is the hypotenuse of the right triangle. Okay? And from that I could use SOHCAHTOA to figure out the height. So sine 12 is opposite 900. So I'm going to use sine 12 over 900 is equal to the sine of 133 over x. If we solve this gives me x sine 12 is equal to 900 sine 133. Divide both sides by sine 12. And x here is around 3165.86 approximately. And now from that, that's our hypotenuse. Or that's this distance, that's the line of sight from the further distance. So now, if I have the hypotenuse and I'm looking for the h, which is the opposite, I could do sine of 35 is equal to h over 3165.86. Multiply both sides by 3165.86. And I'll eventually get the h is 1,816 meters. But if you read the problem, it says that the transit is 2 meters high, so they're taking the measurements 2 meters high. So to find the final height of the mountain, I just add 2 to this. So height is about 1,818 meters.